chemical reaction is in equilibrium when the concentration of reactants and products are constant and their ratio does not vary. The forward and reverse reactions occur at equal rates. K represents the relationship between products and reactants of a reaction at equilibrium with respect to a specific unit. Kp is the equilibrium constant calculated from the partial pressures of a reaction equation.
What is a rice table? A rice table is used in equilibrium chemistry to keep track of the amount of changes a substance in a reaction experiences and to organize a set of conditions that is needed to be followed to solve a problem. RICE stands for reaction, initial concentration, change in concentration, and equilibrium.
We are going to try a practice problem where the initial concentration of a substance is given and we need to calculate the final concentration. The problem we are trying to solve is a mixture of 0.25 molar H2O and 0.25 molar CO is allowed to come to equilibrium. Calculate the equilibrium concentrations of all the chemical species. Kc equals 4.24 at 800 K. The reaction is H2O gas plus CO gas is H2 gas and CO2 gas. The initial concentrations that were given are 0.25 molar for H2O and 0.25 molar for CO gas. The H2 gas and CO2 gas concentration were not given, so therefore they are 0. The reaction is just to the right, therefore it is minus X for the H2O gas and minus X for CO gas, and plus X for H2 gas and plus X for CO2 gas. The concentrations at equilibrium are 0.25 minus X for H2 gas, 0.25 minus X for CO gas, and X for H2 gas, and X for CO2 gas. The expression is the concentration of H2 times the concentration of CO2 divided by the concentration of H2O times the concentration of CO, which equals 4.24. Substituting in the equilibrium concentrations for the concentration of the gases, we get 4.24 equals X times X over 0.25 minus X times 0.25 minus X. Solving for X, we get 0.514 molar. Concentration of H2 gas is 0.154. Concentration of CO2 gas is 0.154. The concentration of H2O gas is 0.25 minus 0.154, which is 0.096. And the concentration of CO gas is 0.25 minus 0.154, which equals 0.096.
Next, we will be solving a chemical equilibrium problem that has to do with partial pressures. The problem we are going to solve is for the reaction I2 gas plus Cl2 gas is in equilibrium with 2 ICl gas at 25 degrees Celsius. Kp is 81.9. If the initial partial pressures are all 0.1 atmospheres, find the pressures at equilibrium and the total pressures.
So now we have to set up our rice table. Remember to rewrite the reaction equation. As stated in the beginning of the problem, we know that the initial partial pressures of the reactants and the products are 0.1 atmosphere. The change in I2 and Cl2 is minus X, while the change in 2ICl is plus 2X. Therefore, the equilibrium pressures of I2 and Cl2 are 0.1 minus X, and the equilibrium pressure of 2ICl is 0.1 plus 2X. The Kp expression is Kp equals the pressure of ICl squared over the pressure of I2 times the pressure of Cl2, which equals 81.9.
By substituting the expression we got from the equilibrium pressures row in our rice table to the Kp equation, we can solve for X. After solving for X and plugging that value back into the equilibrium pressure row of the rice table, you will find that the equilibrium pressure of I2 and Cl2 are 0.27 atmospheres, and the pressure of ICl2 is 0.247 atmospheres. The total pressure at equilibrium is 0.3 atmospheres. The next problem we will be solving is an acid-base equilibrium problem. The problem states 50 milliliters of a 1 molar NaC2H3O2 solution is titrated with a 0.5 molar solution. Calculate the final concentration of HC2H3O2 at equilibrium if Ka is 1.8 times 10 to the negative 5. Now we move to our Rice table. The reaction has to do with conjugates, so it's C2H3O2 minus plus water liquid is in equilibrium with HC2H3O2 plus OH minus. You received the initial concentration of C2H3O2 as 1.0 molar from the problem. Because water is a liquid in this question, it is not included in equilibrium. Both products start off with an initial concentration as 0. This is a forward reaction, so the change in concentration would be negative X for the reactants and positive X for the products. For concentrations at equilibrium, the C2H3O2 is 1.0 minus X, and both products are plus X. The Kb expression for this problem is the concentration of HC2H3O2 times the concentration of OH negative over the concentration of C2H3O2 negative. You are given Ka, so you have to solve for Kb by dividing the Kw value and the Ka value. You will find that Kb is 5.56 times 10 to the power of negative 10. Once you substitute the concentrations at equilibrium row of the Rice table into the Kb expression, you can solve for X. The value of X is approximately 2.357 times 10 to the power of negative 5. Therefore, the answer to this question is 2.357 times 10 to the power of negative 5 molar. Just like